Hello everybody. Now we are in module 5, that is the 5th week of the course, and in this week we will discuss various strategies for minimal processing and hurdle technology in the and its application in fruits and vegetable, and this is one of the very emerging area as far as the fruits and vegetable consumption and its supply chain is concerned. So, in today's lecture 21, we will devote on minimal processing, that is the minimal processing. The concept which we will cover in this lecture include the concept and need for minimal processing, key requirements in the minimal processing of fruits and vegetables, operational steps in minimal processing, quality changes and safety issues related to minimally processed fruits and vegetables. So, let us see first what does minimal processing mean. There are various definitions you may find, that is, someone will say that minimal processing is required for providing least possible treatment to achieve a defined purpose, that is minimal. The processing intervention, packaging intervention, whatever there, it should be minimum as possible, as minimum least possible, so that you get a to get a defined purpose. Or another definition of it may be that the fresh produce subjected to different mild processing steps to obtain a fully edible or natural product while providing convenience and functionality to consumer and ensuring food safety. Another definition may say that minimally influence the quality characteristics of a food, while at the same time giving to the food the sufficient shelf life during its storage and distribution. So, the minimal processing, from the name itself you can also understand that it should be that the material, processed material, it should be as close as possible to its natural counterpart. It is the treatment given to the food material which is minimum extent, and that is to get the desired value, whether it's shelf life extension or processing addition. So, minimally processed food, they undergo a mild preservation process. Product temperature during processing may fall between 0 degree to 100 degree Celsius. They rely on refrigerated storage and distribution mostly. They have a wide water activity higher than 0.85 and a pH higher than 4.5. The examples of minimally processed foods may include that is fresh cut fruits and vegetables. We will devote in this module itself, we will have separate lectures on fresh cut fruits and vegetables. Okay, these are the minimally processed. Similarly, the prepared sandwiches etc., which are where fruits, vegetables, even herbs, leafy vegetables etc., are used, or fruits slices etc., are used for preparing sandwiches etc. So, they are minimally processed, or even ready to eat meals, is also the minimal process. Okay. Chilled prepared foods. So, there may be various categories of the minimally processed foods. Okay. So, advantages of the minimal processing, as I told you earlier, that is it uses the optimized design for preserving foods in its natural form in aspect of its nutrition, safety and sensory characteristics. Okay. That is a comparison here I will give, so to make the point more clear, that unprocessed food, minimally processed food and ultra processed foods. Okay. So, unprocessed food, obviously it is the natural form. When we are talking about fruits and vegetables, whatever it is obtained from the farm, from the field, it is obviously rich in micronutrient, rich in fiber and other nutritional value. Okay. So, the minimally processed food may be that these unprocessed and natural these raw farm produces, they are given some sort of treatment processing and packaging treatment, minimum treatment, which I will tell you come little later. So, they are given like, but they are as close as possible to the unprocessed. They have retained the benefits of the natural form, as well as they also provide longer shelf life, comparatively more shelf life than the unprocessed raw form. However, the ultra processed, they may be low in fiber, they may nutrients etc. may be lost, or there may be presence of synthetic additives etc., depending upon what is the processing technology and what are the methods of processing used, severe processing. So, it results in the loss of micronutrients etc. So, this minimal processing technologies have emerged to replace traditional methods of preservation while retaining nutritional and sensory qualities. This is coming in a big way in the fruits and vegetable processing, as I told you earlier. Minimally processed foods have similar characteristics to the whole original fruits or vegetable and could be used readily without further processing before use. Minimal processing provides the advantage of convenience to the consumers. Okay. So, let us see what are the different technologies that can be used for minimal processing. The minimal processing technologies, that is the major categories of the minimal processing strategies may include, that is one is that optimization of the traditional preservation methods itself, whatever the drying, smoking, canning etc., which is being used. So, these traditionally used processes, they are optimized in such a way, so that you give minimum possible heat requirement, minimum possible other conditions etc., salt and other things, and so that you get improved organoleptic properties and maintain nutritional value with the concern of microbiological safety etc. So, that is one way. One way of minimal processing may include that optimization of the traditional preservation methods to get better result, particularly better, or to reduce the severity of the traditional method, so that you can get better nutritional value. Other, obviously, use of mild or no heat treatment, such as novel preservation techniques like infrared heating, microwave heating, high pressure processing, ultrasonication, pulse electric field processing. So, these are the novel advanced thermal technologies or non-thermal technologies which can be used. By this, one can reduce the severity of the processes and get better nutritional and health effect. And then finally, that is used by using synergistic effect, that is the combination of technology, that is the hurdle technology concept. We will take up this again in little detail, separate lecture on this hurdle technology, where various technologies like temperature, water activity, pH, oxidation reduction potentials, use of various chemicals etc. So, the combining various preservation effects, one can reduce the severity of the process, then we can have a better nutritional value or better effects. Okay. So, the minimal processing, we say that is, it may be thermal technologies like optimized traditional method, as I told you, mostly at present, that is the thermal technologies are used. So, they can be optimized, like better to go for high temperature short time methods, aseptic processing, semi aseptic processing, or Sovos wide, or even non thermal or novel technology, novel thermal technologies like infrared heating, ohmic heating, microwave heating, radio frequency heating. So, instead of steam and traditional heat process, you can go for the advanced or novel heating methods. So, they result in the better quality improvement. Then the non-thermal technologies may be ionizing radiation, high pressure processing, pulsed white light, ultraviolet light, laser light, pulse electric field, ultrasound, plasma sterilization, ozone treatment etc. So, these are the various non-thermal technologies which can be used for minimal processing. So, now another aspect is the packaging, that is modified atmosphere packaging, control atmosphere packaging and storage, vacuum packaging, gas flushing, edible film, edible coating etc. They can also, in the earlier lectures in the last modules, we discussed details of various packaging materials etc. So, they can all be considered or used for minimal processing. Then sometimes use of natural preservatives like antimicrobial proteins, plant derived antimicrobial agents, natural antimicrobials, etc. are hard technology. As I told you, combination of technology can be used. These are the different minimal processing technologies. Okay. So, let us have little details of this, that is minimal thermal processing. Thermal processing, as you all know, it leads to undesirable changes such as loss of vitamins, mineral, texture, flavor, and formation of thermal reaction components of biopolymers, etc. So, using minimal processing strategies, that is the traditional thermal technologies, either they can be replaced by STST method, aseptic processing and packaging methods, or go by the Sauvis wide processing, actual cooking of raw material under vacuum and then package, etc. So, use either traditional processes, that is STST, because in high temperature short time if you go, that is particularly for the sterilization or ultra high temperature treatment. So, at a very high temperature, that is 150, 160 degrees Celsius or above, the rate of the bacterial inactivation is very fast, but the nutrient destruction is comparatively. In the earlier classes, we saw the comparison of Z value of the nutrients and Z value of vitamins, etc., and how the temperature. So, at a higher temperature side, so Z value for the microorganism less, whereas the Z value for the nutrients, vitamins, etc., is high. So, they are more resistant. So, that is taken into advantage in the STST processes, etc. So, aseptic methods and ultra high temperatures. Okay. So, these are the they can be considered as minimal thermal processing strategy, thermal processing technologies. So, even the novel methods, as we saw, that electromagnetic waves that can deliver heat to food selectively and effectively, like microwaves or radio frequency waves, they interact with the water in the food to heat the by induction or by dielectric heating. These are the volumetric heating, internal heating. So, not very, that is movement and thermal conductivity and all those problems are not there. So, better material gets heated by volumetric and the nutrients, etc., is their destruction is less. So, it is a more efficient, shorter duration and lesser change in the food component as compared to the conventional methods. These are the, see, you see that this is the microwave oven here. These are the microwave is coming and the food material is kept in this. Okay. Similarly, that radio frequency generator, this between two electrodes, the product is kept and it is given for a short time. Then the ohmic heating, here alternating electric current is passed through the food, where heat is generated due to electrical resistance. It provides quick and consonant heating, resulting in a less thermal damage or better nutritive value. Okay. This is the thing, you can say that yes, these are the electrode and the food material is given. So, electrical current is given, that is ohmic heating. Okay. Then minimal non-thermal processing, can say that is irradiation. In the earlier class, we discussed in detail about radiation technology and its application into fruits, vegetables, spices, etc. So, that is the one. It can also be, if it is properly optimized, it can also be considered as a minimal processing strategy. Then another very, very emerging non-thermal processing, which can give better quality, okay, therefore can be considered into minimal processing strategies, is the application of high pressure processing. That is high hydrostatic pressure, maybe up to 400 to 600 megapascal or sometime even more, 800 to up to 1000 megapascal. So, this material is subjected either in the packaged form or unpackaged form, at the case maybe mostly the fruits, vegetables, etc., in the package, that is a airtight or hermetically sealed packaging, etc., if juices, etc., are there. So, depending upon the type, this can be, and this is put into a high pressure chamber, then high hydrostatic, with the help of the certain pressures it is pressed, and then this, because of the pressure, application of pressure for a short period, it inactivates the microorganisms and enzymes, etc., and then extend the shelf life. Okay. And it is in my other course, NPTEL course in novel technologies on food processing and shelf life extension, we have elaborated, I have elaborated these high pressure processing and other novel technologies. So, if you are interested, one can go. Similarly, the minimal non-thermal processing may also include pulse electric field processing. It applies short pulses of electricity for microbial inactivation. It generates electrical fields with the help of short high voltage pulses between two electrodes, and product placed between the electrode experience a force per unit charge which ruptures the bacterial cell membranes. And one very interesting application of pulse electric field is also for in fruits and vegetable, getting fruits and vegetable juices with better enhanced nutritional value, which can nutrient, because if you give this PEF treatment for a short time, of course, it has to be optimized properly, then this fruits cell wall of the fruits and vegetables, it gets ruptured, and then juice recovery is better, and with even minimum application of pressure. Otherwise, if you go extraction of juice with the pressing technique to expelling, it generates a lot of heat, and which causes the inactivation of the nutrients and bioactives. So, this PEF treatment, if it is given for a short duration, so it ruptures the bacteria, that is vegetable tissue cell matrix, and then you get better juice extractability with better bioactives. Similarly, ultrasonication is US mechanical waves having ultrasound mechanical waves having frequency more than 20 kilohertz. This causes acoustic cavitation in food and results in heat, shear force and free radical formation, and this also can be US assisted extraction of the juices and bioactives, etc., is coming in a big way. That is, then pulse light processing, that is decontamination of food by applying highly concentrated energy as broad spectrum burst 1 to 20 flushes per second are applied, and it has the photochemical and photothermal effect of the microbes and enzymes. Ozonization is coming. Ozone is a powerful oxidant effective against the various microbes, etc. Ozone auto decomposes to O2 molecule, leaving no residue. It is considered to be a greener food additive. It has been permitted by FDA, etc. You can see in this setup here the orange juice is being treated with the ozone. So, you get its packaging itself life extension. Okay. Then after processing, the packaging interventions, like these are the widely accepted techniques for under minimal processing strategies, particularly for the whole producers, etc. Okay. There may be vacuum packaging, gas flushing like nitrogen packaging, argon packaging, or carbon monoxide or carbon dioxide packaging. It may be controlled atmosphere packaging like protein based edible films or lignin based coating films, or polysaccharide based coating films, or composite coating, etc. So, in the earlier lectures in the last module, we discussed details about the various packaging methods and packaging technologies for the fresh produce, and this can be used for even the processed products also. So, that is one basically modified atmosphere packaging. We already discussed earlier, so I will skip here. MAP, it relies on the changing the surrounding gas composition by interplay between the film permeability to gases, that is O2 CO2, and respiration rate of the product inside the package is controlled, so that to get better shelf life. Similarly, edible coating also, there will be coating with polysaccharide, protein, lipid, composite, plasticizers or surfactants to improve the adherence. Even the coating material can carry antioxidant, antimicrobial, active ingredients. And then examples may be ascorbic acid, which prevents enzymatic browning, then organic acids, which are antimicrobial. So, it improves the barrier properties O2 CO2 ethylene, it gives a moisture barrier, mechanical resistance, retention of volatiles, retention of functional compounds, etc. So, that is edible coating is another emerging minimal processing or packaging strategy. Okay. So, now let us say what are the operational steps of minimally processed fruits and vegetables. Okay. Obviously, that is in the field, which is in the field area, which is normally not a controlled environment. You can say open environment, it may be various pollutions etc. might be there, but one has to take care for minimally processing strategy, starting from harvesting, transport, pre-cooling, chilling, storage, whole produce washing, sorting and grading, cooling and trimming operations, all this. So, maximum allowable temperature for all these operations is given here. Like for example, harvesting, it should be 25 to 30, but other operations, transport 10 degree, pre-cooling and chilling storage 5 degree, all right. Trimming operations should be done at 10 degree. So, means that temperature should be maintained in each and every step, so that any possible destruction of the nutrient or change in the composition etc. nutrients, bioactives in the fruits and vegetable can be minimized, because these all fruits and vegetables, they are hub of the bioactives. Then after that it comes into the processing area, which is a comparatively clean area, but still like disinfection, washing, rinsing, dewatering and spin drying, wet and optional mixing, then active and passive modified atmosphere packaging, wholesale or cold storage, and then cold transport and distribution. So, all this again the temperature at each and every step, maximum allowable permissible temperature, so that you get better quality is indicated here. And then ozonation or disinfection with natural preservatives or vacuum packaging, modified atmosphere packaging, gas flushing etc. This can be used for various. So, these are the different operational steps for minimal processing. They can be properly graded, sorted, cleaned, okay, and washed, sanitized, packaged and kept. So, that you get better shelf life, extended shelf life, better quality. So, the key requirement now in minimal processing of fruits and vegetable is that number one, the raw material should be of good quality, that is, it should have a proper cultivable variety, cultivar variety, and correct cultivation, harvesting and storage conditions, that is important. So, have strict hygienic and good manufacturing practices like HACCP etc. should be followed, low temperature during working, careful cleaning and or washing before and after peeling, water of good quality like its sensory, microbiology, pH etc. there should be good, and that should be used. Potable water of good quality should be used for washing purposes, mild additives in washing for disinfection or browning prevention etc. Gentle spin drying after washing, so that the surface moisture is removed, gentle cutting, slicing, shredding, correct packing material and packing methods, and correct temperature and humidity during distribution and retailing. So, these are the key requirements of minimal processing of fruits and vegetables. So, here in this table I have given the main requirement of commercial manufacture of fresh peeled, pre-peeled, sliced, grated, shredded fruits and vegetable produce according to the European Union guidelines, that is for the almost for minimally processed fruits and vegetables, almost all fruits and vegetables, that is they should be standard kitchen hygiene and tools, no heavy washing and peeled and shredded produce, packages can be returned, returnable containers etc. Similarly, so they can be made like prepared today and to be eaten tomorrow. It is the European Union guidelines, are prepared today and eaten within 3-4 days, are prepared and intended for use into retailing points and sale up to 7 to 10 days. So, that minimal processing, what is your target, accordingly what are the different steps that should be used, and which are the vegetables or fruits suitable for this, like for the prepared today and eaten within the next 3-4 days, like carrots, cabbage, baby leaf, iceberg lettuce, rockets, potatoes, beetroots etc. They have shelf life of about 3 to 5 days. Okay. And here the steps that is requirement for processing, minimal processing, disinfection by water washing or exposure to disinfectant, gaseous agents etc., washing of the peel, shredded produce at least with water, permeable packages, potatoes are an exception, that is other than potatoes they can all be used in proper permeable packaging materials etc. Then let us see quality changes in minimally processed fruits and vegetables, like there may be physiological changes, enzymatic browning of fruits and vegetables caused by polyphenolic oxidase enzyme, lipoxygenase catalyzes peroxidation resulting in the formation of foul smelling aldehydes and ketones. There may be increase in the ethylene production, the respiration activity of produce may increase, then anaerobic packaging conditions will lead to anaerobic respiration, etc. So, depending upon what are the during minimal processing also the care should be taken that there is a minimal physiological desire like tissue softening or enzymatic browning, etc. should be. So, earlier also we discussed on these things. Then similarly microbiological changes, because minimally processed vegetable most of which fall into medium or sub-acidic range, the high humidity conditions and large number of cut surfaces provide ideal environment for microorganism development and retail establishment. Okay. So, these during cold storage of minimally processed baby leaf vegetables, pectin lytic strains of Pseudomonas are responsible for soft rot symptoms, etc. So, again the care should be taken, and increase in the storage temperature and CO2 concentration under package will shift composition of the microflora such that lactic bacteria tend to predominate among the microbial population. So, these are the possible changes one should take care. Similarly, nutritional changes might be there, but although aim of the minimal processing is to have maximum retention of nutrients and at the same time adequate safety. So, studies in fresh cut pears, apples, kiwi fruits and melons found that sugar level do not vary substantially under refrigerated conditions. No significant changes were observed in the citric acid, malic acid and amino acid content of fruit sample stored under refrigeration. Ascorbic acid, however, and the certain vitamins were shown to be influenced by atmospheric conditions. Ascorbic acid and vitamin content of kiwi fruits stored under different environmental conditions for various days, they were found changed. So, this condition should be in the minimal processing, it should be there is proper steps should be followed, so that the nutritional changes. Then the safety issues with the minimally processed foods, like factors that affect the minimally processed fruits and vegetables, decay and shelf life, obviously because they are sometimes that is they are peeled, shredded and then packaged and afterwards. So, there may be during these operations if there is a mechanical damage, that is a dehydration or decay, etc. This may act as a vector for microbial growth, etc. or oxidation, because enzymes may get released. So, that may cause the safety issues. Similarly, microbial growth like spoilage and pathogen growth, etc. or physiological aging, these are that the dehydration, increasing the respiration rate, ethylene production or loss of appearance, etc. tissue softening we saw in the earlier slides, or their biochemical changes like surface browning, softening, loss of texture. So, even all these biochemical reactions, etc., sometimes even browning end products of the browning reaction, they also may be toxic at times, you never know. So, that becomes very important, that is in the minimal processing, while we give the treatment in such a way, in the proper whatever where you are going either non-thermal or thermal or processing or other packaging technology, it should be done in such a way, so that all these parameters, etc., biochemical changes, physiological changes, microbial growth, etc., or mechanical damages, etc., should be prevented. They are prevented, so that there is no safety issues, it is safe to consume, but at the same time it is good. So, obviously, the agricultural produces mostly have a neutral pH and high water activity, that is favorable for the growth and survival of the pathogenic bacteria. The presence of pathogenic microbe in the agricultural produces can be prevented only by good agricultural practices and good manufacturing practices. Minimal processing causes damage to plant tissues, which dramatically increases the physiological activity and lead to senescence or deviation in the metabolism. So, the care should be taken. Packaging may generate atmospheric modification by respiration of the plant tissue, which in turn may cause fast fermentative changes and spoilage. Okay. So, the packaging, even MAP and all those things, it should be there that anaerobic packaging, it should, material should respire anaerobically, otherwise it will, if respire aerobically, sorry, otherwise if aerobic respiration is not there, then anaerobic fermentation and material will spoil, which may result into safety issues. To prevent growth of foodborne pathogen in these foods, storage temperature and shelf life are critical factors. They should be refrigerated during their shelf life to retard or prevent the proliferation of undesirable microorganisms and to delay biochemical changes. Okay. So, finally, I will summarize this lecture by saying that minimal processing mildly influence the quality characteristics of a food, while at the same time it gives the food sufficient shelf life during storage and distribution. Minimal processing can be applied through optimization of conventional methods or by application of novel preservation methods, and then by using even combination of both the hurdle technology. Thermal, non-thermal novel preservation methods, packaging methods such as modified atmosphere packaging, active packaging, edible coating, etc. are used to produce minimally processed food. Minimally processed fruits and vegetables may make the product more susceptible to physiological, mechanical and microbial damage. So, the processes should be conducted properly. Storage temperature and shelf life are critical factors to ensure safety of minimally processed foods. Okay. So, that these are the important considerations. These are the references which are used in this lecture. Okay. This, I really thank you very much for your patience.